Welcome back, everyone. We are now in 12.7 dealing with congruence in overlapping triangles. And one thing that actually will make things easier or will simplify our work is if we can physically separate the triangles, either redraw them on the paper, or if you are good enough in your head to be able to separate them and think about the triangles individually to prove congruence of other shapes. Please make sure you've worked through the first part of the lesson and then come back when you think you have the answers for the got it. One thing that I think is really convenient when approaching problems like this is to be able to highlight or color code. So if I look at triangle ABD, it's this right triangle using the bottom and the left side and then my hypotenuse across the middle. And then triangle DCA. DCA is again a right triangle, but now my hypotenuse is crossing the other direction. I'm using the right side and the bottom, so they both share this bottom side here, or AD. So again, I set up my triangles by highlighting. I have the right triangle that uses the left side here and the bottom and then my hypotenuse, and then I have the right triangle that uses the top, my left side and the hypotenuse. So the shared side there would be AB. Go ahead and try practice problems 1 and 2 on your own. Pause the video and come back when you want to check your answer. Here in 1, DF is actually the only shared side. They share vertexes between them, but they do not share any angles between the two triangles because my red triangle here is on top and my blue triangle here is on bottom. In number 2, if we were to look at JKL, so it'd be this triangle here, and then MLK, I could separate both of them and actually it would look like this. And I would then see that KL is the only common side between them. Please make sure you've worked through the next part of the lesson and have tried the got it before coming back here for the answer. So when I look at these two triangles, I've got CAB highlighted here and BDC. And what I know is that these triangles are congruent. So what that also tells me is that this small angle in the blue triangle and this small angle in the yellow triangle must be congruent to each other. So then this triangle BEC down here must be an isosceles triangle because I have two base angles that are congruent, which satisfies the definition of an isosceles. So then that tells me since those two base angles are congruent, the sides opposite the angles must be congruent, and that is the BE and CE that we were looking for, or if you'd like it written out in another way, there you go. Go ahead and try to complete this proof, filling in all the reasons for A through E, how we know these angles are congruent, how we know the side is congruent, then how we know that my triangles are congruent, and then how we know these angles are congruent, exactly what we're trying to prove. So when we start looking at this flow proof, we see that my angle T is congruent to my angle R. I know that PV is congruent to PQ, and I'm trying to prove that PQT, this angle right in here, and PVR, this angle right here, are congruent to each other. So I start by knowing what's given to me, so angle T is congruent to angle R by given. Then by our reflexive property, we know that angle TPQ, this top angle here, and RPV, this same top angle here, are congruent to each other because they're the same angle. That's exactly what reflexive means. Then moving on, PQ congruent to PV. Well, again, that was given to us. But now because I've proven these two angles and this side congruent based on where they are in the triangles, I can say that the triangles themselves are congruent by angle, angle, side. And since I now know that the triangles are congruent, angle PQT and angle PVR are actually corresponding parts of the triangles, so I can prove this statement by CPCTC. When we look at the proof of number 4, we're approaching it knowing that QD is congruent to UA. My angle QDA and my angle UAD are congruent, and then right here, highlighted in blue, I see that these two triangles share a sides, because if I look at triangle QDA, I'm looking at QDA and then back up here, so I have this side DA. Then UAD still uses that side. So I can actually prove these triangles congruent by side, angle, side. And there we have our proof. So make sure you've worked through the next part of the lesson to make it to this got it. Try and solve it on your own, so pause it right now, see if you can make the breakthrough that lets us prove that QPT is congruent to QRT. So when I start looking at this, QPT is, T would be right here, S is down at the bottom, and then QRT, so I've got this left triangle and this right triangle here. Now, I'm not given any information about those triangles, but I am given information about a larger triangle here. So if I look at QS being congruent to RS, and the angles right in here being congruent, I've got a side and an angle right next to each other that are congruent, and then what I see is I have a shared side right here, or I can even go longer than that and say I have a shared side right here. So now I could look at the triangle QPS being congruent to QRS based off of a side angle side relationship. Likewise, I could state, if I highlight only to there, that PST is congruent to RST also for side angle side. So now I've got multiple sets of congruent triangles. This is like what the plan question is asking you. How do we know what triangles will be helpful? Well, I need triangles that are going to include this triangle and or let me see based on the addition postulate, like segment addition postulate, what parts are congruent. So right here is the proof written out showing that after we prove the congruence in our triangles, we can then make those statements up here, because we also know that congruent parts of or corresponding parts of congruent triangles are congruent, so we'd know that the big angle P and the big angle R would be equal to each other. The angle SRT and the angle SPT would also be equal to each other, which then makes this angle here and this angle there equal to each other based on either the addition postulate or any other of the few theorems or postulates that we have. Go ahead and try number 5 on your own to write out the proof. It's pretty quick actually, because I have a bisector, or a midpoint, So because of that midpoint, I know that FD is going to be equal to DB just based on the definition of the midpoint. So pause the video, try to solve the rest of this, and come back for the solution. Always remember vertical angles, because they will help you immensely in saving time in proofs. I have 2 sets of vertical angles here that I can use, but really the set highlighted in blue is what I'm going to care most about, since the triangles I'm dealing with are ADC and then EDG. So if I look at the set in blue being congruent and the set in purple being congruent, since the larger angle ADC and EDG are the combination of the blue and purple, then I'll know that those will also be congruent. So here is a sample of what your proof might look like. Alright, so when we look at the got it here, we have a few different triangles here all overlapping. So a little advice here, you may find it helpful to separate them and draw a diagram of each pair of triangles that you're looking at. Now I cannot separate this image, but I am able to highlight what we're looking at. So CAD would be this angle tucked in there, and EAD would be this little angle up in there, and then angle C equal to angle E, that is this angle and that angle. And what else I see is that AD is shared between both of these triangles if I connect and form triangles. So I can connect right here and I can connect right here, and now I have 2 triangles that I can prove are congruent because I've got congruent angles, and then a congruent side, and I can use angle, angle, side to prove that congruence. So once we have those triangles congruent, and actually to pause just a moment, I wanted to make note, this symbol right here means actually congruent angles. So it's talking about, and the 2 given pairs of congruent angles, those would be these pairs of congruent angles. So we know these triangles are congruent by angle, angle, side, and then we know based off CP/CTC that side CD would be equal to side ED. So that's CD here equal to ED there. Then we have vertical angles right here with BDC and EDF. And once we know that, we can prove that these 2 triangles are congruent based off angle, side, angle. And then because we have congruent triangles, we can use CP/CTC to satisfy the statement that we were trying to prove. So I'm starting here in number 6 by highlighting for you what we're trying to prove is congruent. So we want to prove that QET is congruent to QEU. So go ahead, look at the given, and decide a plan that you might use to try to approach solving or proving these triangles congruent. So one of the first things I notice when I'm looking at my given pieces is angle 1 is congruent to angle 2, top to bottom. Angle 3 is congruent to angle 4, top to bottom. And I have a shared side between here. So if I look at the triangle QTB and the triangle QUB, we could prove these congruent based off angle side angle congruence. And since we know those triangles are congruent, I can then say that QT is congruent to QU because of CP/CTC. And then by our reflexive property, I can show that QE will be congruent to itself. And from there, I have a side, an angle, and a side. Remember, my angle is included between my two sides, but I can prove these two triangles congruent. Try 7 and 8 on your own. This should look familiar to you. There are the only shared pieces. We have a shared side on number 7 and a shared angle on number 8. Then try 9 and 10, where you're going to have to separate and redraw. So you want to pull the two different triangles that you see apart from each other. Label all your vertices too, because this will tell you what is overlapping. Hopefully you were able to draw something pretty close to here. We see that NP would be a shared side in number 9, and we see that B would be a shared angle in number 10. And with that, we end our lesson for today. So please let me know if you have any questions, comments, or concerns. Make sure you get that practice work completed and come to class ready for your test.